Okay, so now we can simplify this, right? So we have x is equal to, so we do the same 118.5 plus or minus the square root of, let's further simplify what is the bracket. So you can punch 118.5 minus 4 open brackets
by 985.5.
yeah.
It's giving me a negative
Mm-hmm.
3,823.5.
Okay, so
3,
3.5.
negative 382.
Two, yeah, that's it. Let me write the 2 properly.
Mm,
Okay, so 382, then 3.5.
3.5, yes.
Okay, so divided by negative 6, right?
Mm.
So
We
what do we
have
have? We have
37.25.
that is a square root.
No, when I
Mm.
do, when I divide,
Oh,
there's negative 382.23.5 divided by negative 6.
oh, have you? We should first get the square root.
Just the way it is.
Yes,
Or before dividing.
yes. Though I'm seeing something fishy.
Okay.
Yeah, I'm seeing something fishy here. Our a was what number? Negative 3, right?
Yes.
And our c was
She was ABC. Yeah, I didn't even write it.
oh, okay, I see. Yeah, because we shouldn't have a negative under a square root like that.
Oh.
Yeah, it means that something is wrong somewhere.
The negative, yeah, I think the negative 3 is supposed to multiply by a negative. This is a positive, not?
Which one?
Mm,
Because in the
the
brackets we
negative.
have negative 3 and
Mm,
negative 3 there, which shouldn't be the
mm.
case.
Oh.
It means that something is wrong. It's either, so if the negative 3 is okay, then this number here shouldn't be negative.
The upper one.
Yes. So I don't know where we have gone wrong, and we have erased all the
Maybe
memory.
yeah.
Okay, just a second. Let me see. There's a way. Hoping it's this one. Finish that. Then we're just going to add this. Uh-huh. So I see where the problem was. Okay. So this is for yesterday.
Yes.
We have negative 3 squared, this and that, plus. Yeah, but
1, 2.
yeah, but already this is a negative.
Mm.
But I'm wondering how, because this is a negative.
Mm.
Okay, where is the issue?
Let me see. 1,200 minus 1,528. Yeah, it's a negative.
Yeah, it's giving us a negative, which is
Mm.
shouldn't be the case. Shouldn't be the case. Let me look at the. Let me analyze this question. There's no way that we can have this
Yes.
complication. Ah, okay. I see. I see where we made a mistake.
Okay.
It's this. So first of all, let me rewrite the question the way it is. So the question is saying that total cost. So the total cost is supposed to be, so the total cost is equal to, here it's q to the third power minus 61.25. This thing is tripping today. 65 q squared, and then plus 1528q. Okay, 28q, and then there's plus a constant there. So we know that when we get the change in total cost due to change in output, we are going to get 3q squared. You see that, right?
Yeah.
But in our case, this was negative. I don't know why.
Oh.
So this, the negative 3, the a was negative. Remember, we are saying we are multiplying by negative 3 here.
Yes.
Which shouldn't be the case. There's no way these numbers, both of them can be negative.
Okay, so it's just 3.
Yeah, so this is supposed to be positive 3.
3. Okay.
So that when you multiply this times that, the inside answer here should also be negative. Because the key is that when we do the multiplication throughout, we shouldn't have a negative number under the square root.
Okay.
Because there is no root for a negative number. So that is what the catch is.
Okay. So we just remove the.
Yeah. So we just rewrite. We just remove the negative here. This one we put it positive, which means that when you multiply now 3 times negative 3 to 8.5, we should get a negative number in the brackets here.
So that we add.
So now this will be. So what you can do is you punch the 118.5 minus 4 times, or in short, we know that when we multiply this number in the brackets, which is negative, times the 4, we should get a positive number.
Yes.
So try to punch that. We see what we're going to get. Just this 118.5 minus 4 times negative 985.5.
Okay. 118.5 by negative 4. And then by again, negative 985.5.
Yeah.
I have a 467.
So that's a positive number, 467, right?
Yes.
Okay, so which means that what should be under the bracket is that positive number.
Yeah, 467.
So 467.
No
point.
There's a 0.127.
0.127. Yeah, this is not making sense. Okay, so what
So
you do is
negative 6. So we also need to remove the negative. Is it correct?
Yes, because this is now positive.
Yeah.
Yes. So now can you try to punch this? So what you do is find first the square root of 467.127.
Okay. Square 467.27. I have a 21.
Okay, so you have 21.
Point 0.61.
0.61. Yeah, so we have got 118.5 plus or minus. The square root of that number is this 21.61, right? Then everything divided by 6. Right?
So do I divide?
Yeah, so now we say x is equal to, so now we can split these because we have got plus or minus here in between, right?
Yes.
So this means that we have two functions. One is 118.5 plus 21.61 over 6. Then the other one is 118.5 minus
21.61 over 6. Okay.
So okay, try to do the one on top.
1.5 plus 21.61 over 6.
Yeah.
I have a 122.
So you have 122 just on top.
Yes.
Divide that by 6.
I have done that.
Oh, so the actual answer is
122. There's a point 10. I don't know if it should be picked or we can neglect it since it's.
So you've done 118.5 plus 21.61. You found the answer. That answer divided by 6 has given you 122.
Yes.
So 122.1.
Yeah.
Okay, so that's the first value for our output, right? Then do the second one for minus now.
118.5 less 21.61 over 6.
Yeah.
I have a 114.
So 114.
Point.
Yeah.
8.89.
0.89. Okay. So it means that we also have, so we have got Q1 and Q2. Which means that this same can produce either 121.1 or 114.89 units. But this firm, what we know is that it's supposed to produce one level of output. And when both answers are positive, you get the bigger one.
Okay.
So since the question is saying compute the profit maximizing output level. Okay, so in this case, since we had the quadratic equation, we found two output levels. We found Q1, we've also found Q2. So what it is when you have such a case where both output levels are positive, get the bigger one.
Okay.
So we get the bigger one. That's the first rule. The second rule is that if one is negative, one is positive, get the positive one because you cannot produce a negative output.
Yeah.
Yeah. So
in this case, we'll get the 122.
Yes. So in this case, yes, we get the 122 and not the 114.
Okay.
Right.
Right, sir.
And then yeah. So we have that. The second question is saying, where is that? Yeah. So this question is actually we've not finished. Because it's saying and ensure that the sufficiency condition is satisfied. So what we do is, in short, we are getting the second order condition. We check whether when output is 122, this is really going to be the maximum.
Okay.
Whether profit is going to be maximized when you produce 122.1 units. Okay. So we can check yesterday's equation. So we had that equation as our first order condition equation.
Mm-hmm.
So let me just take note of that. Okay, perfect. Yeah, so our equation was, our first order condition was, so we said that it's supposed to be 3q squared minus 4q minus 4q and then plus 122.5 q, then plus 1200, then minus 1528.5. So we know that this is going to equal 3q squared. Then when you do negative 4q here, this is what we are getting plus 118, right? 0.5 q, and then here we are getting, I've forgotten the answer. What was 1200 minus 1528? What were you getting?
1000.
1200 minus 1528.5.
128.5. We got a negative 328.5.
Okay, so it was 328.5, right? So we are saying that this is the first order condition.
Yes.
So this was our first order condition. So now we should get the second order condition.
Yeah.
Which is we are going to redifferentiate this with respect to q. Alright?
So we'll have q.
Yeah, we'll have 6q plus 118.
1.5.
So as usual, this should equal to
0.
No, because remember it's a second order condition. We want to check if we want to check what will happen when q is 112. Right? So again, this equation is revealing something funny. Because when you look at it, it's showing me that, because if we put our q there, just a second, this pen I'm using to, it seems to, the pen I'm using to write seems to, like the ballpoint seems to have an issue. Let me just change it.
Okay.
Okay, so yeah, I was saying that this thing here is revealing something funny. Yeah, because when we put our q here, this whole thing is going to be positive.
Yes.
And we know that when f xx is greater than 0, we have a minimum. You see
Yes.
that? But what we are saying is, what we should find is that after putting the q here, this fxx should be less than 0, so that we can have a point where profit is maximized, not minimized.
Oh, yeah.
So this is where the issue is. I don't know where exactly. I don't know where exactly we have missed it.
Hope it doesn't bring decimals.
Yeah.
That was a trick.
Yeah. Okay, but generally, the concept.
This is a concept.
Yeah. Have you understood the concept?
Yes.
Yeah, because the assumption now will be, or if you have gotten the concept, then it would mean that we are on the safer side.
Yes.
So if the concept is understood, then we are on the safer side. Okay, so now if you have gotten the concept, I'll try to look at it on my own to see whether we've made the mistake.
Yes. Okay.
Yeah, but if you have gotten the concept, well and good, because the concept is what really matters. If you're able to do it on your own, then we're on the safer side.
Yeah.
So which means we can try question D, right?
Yes, let's look at it.
Which is saying how much profit will be generated by the firm at the profit maximizing output. So assuming that our output, our 1 to 2 point, I don't know, is it 1 to 2.5? Okay, so our this output, okay, at this level of output 1 to 2.5, we know that profit is just the difference between total revenue and total cost. Yes, so we have we can set up this. So our total revenue function, we have our total revenue function, or in short what it is you get the total revenue function. Where there is q, you replace it with 1
We
to 2.
substitute.
Yes, you substitute and find the value of profit. Yes.
Okay.
So you can
That's
do that,
fine.
right? That's fine, right? So you just substitute.
Okay.
Basically you just substitute. So where there is q, you set up this function, profit is equal to total revenue minus total cost. Then you put the equations. After putting the equations, then you replace. Where there is q, you substitute. Where there is q, substitute to find the profit value. Yes. Okay. Meaning that that's with optimization.
Okay.
That's with optimization. Can we try integration now?
Yes.
Okay. So with integration, the first one is saying that okay, so the first one is saying, can we integrate? So can we integrate 4x to power 3 with respect to x? So we know that this is just going to be 4x with the power, we increase it by 1. So this would be 4x to the power 4 over 4, right?
Yes.
Yeah. Then plus a constant c, since this is indefinite integral. So
Yes.
we divide. 4 into 4 is 1.
Mm-hmm.
So practically we have x to the 4th power plus a constant c.
Okay.
That's okay, right?
Yes.
And then with b, we have we are integrating x to the power 1 over 5
Mm-hmm.
dx. So this is the same thing. This would be x to the power 1 over 5. So what we know is that in this case it makes more sense to convert it into decimals.
To do what?
To convert it into decimals. The
Okay.
power.
The
Yeah.
1 over 5, the power.
Yes. So 1 over 5, this will give us 0.2.
0.2, yes.
So it's more like the function is integrate x to the power 0.2.
0.5 or 0.2, okay.
Yeah, 0.2. Right? So we know that
Mm-hmm.
when we add 1 to 0.2, this will give us 1, 1.2, right? Then divided by 1.2, then plus a constant c, right?
Okay.
So far so good, right?
Mm-hmm.
So we can just divide because we know that here there's a 1 here.
Mm-hmm.
Yeah, so we can just say 1 divided by 1.2, right?
Yes.
Now it's giving us this funny fraction, this funny decimal. It's going. So what we can do is just to avoid this complication, we can just rewrite it that this is 1 to the x to the power 1.2 over 1.2 plus c, just like that. We leave it as a fraction.
Just like that. Okay.
As a fraction, right?
Mm-hmm. Right.
And then for the other function, which is so c is this one, we are integrating the square root of x with respect to x. Okay. So what we know is that every time we have a square root of something, it's the same thing as saying x to the power 1 over 2.
Okay.
So in short, when we have a function a, the square root of a, this is the same thing as a raised to the power half.
Okay.
Yes. So in this case, it's more like you're getting the integral of this. X to the power half dx. So it will be the same thing. This is x.
Plus 1.
So this would be half plus 1. So half is 0.5, right? So half plus 1. This will give us 1.5.
Yes.
So it's the same thing as saying 1.5 over 1.5 plus a constant c. So let's also leave it as a fraction to avoid issues.
Okay.
And then for d, over here, down here, we are integrating 5x to power 3 plus 2x to the power 2 plus 3x, everything with respect to x, dx. So this will be 5x to the power 4, right?
True.
Everything divided by 4, then plus here to be 2x to the power 3 now.
Yes.
Over 3, then here plus 3x squared over 2, right? Plus a constant c. Plus a constant c. So since there is no proper fractions that we can
Like here, is it right simplify to go further, or we just end here?
No, we can end here because 4 can't go into 5, 3 can't go into 2, and 2 can't go into 3, like definitely.
So these we treat these as independent fractions.
Yes, we treat these as independent fractions.
Okay. I was thinking maybe you can cross like 3, 3, 2, 2.
No.
Okay.
No, unless if they were multiplying.
Oh.
So if it's addition and subtraction, we leave them just the way they are, like that.
Okay. Yeah.
But
that's a question I have.
Word of caution, okay? If it was, let's say, if it was something like, let's say the first part was 10 over 5, then x to the power 5, like that. 5 can go into 10 2 times.
Yes.
So that would have been forced to say the answer is 2x to the power 5.
True.
Like we could have simplified. But the way they are, let's just leave them like that. It's okay.
Okay.
So far so good, right?
Yes.
Can I erase this?
Yes, please.
Okay.
So if it's multiplication and the fraction that you have and the next, you can, like, they have even numbers which can probably be crossed. You can do that.
Yes, then you can do that. It's okay.
So the other part of this, we have definite integrals.
Yes.
So with that introduction of the number up there, at integral,
yeah,
and you have a 0 down there.
So with this one, oh yeah, with definite integrals, we integrate over a given area. Yeah, so that is why there and every time we are doing the definite integrals, we don't add the constant.
Okay, that's a difference.
That is the difference. So with the definite integrals, one, there will be a number, there will be those numbers given, like the area over which we're integrating. Okay, then the other thing is that we are not going to add the constant with definite integrals. We don't add the constant. Please don't make that mistake. Do not add the constant. Okay, so we can progress, right? Okay, perfect. So this question 4, is a question that gives more like, maybe it can give us some problems, but not really. Let's just quickly talk about 2 concepts.
Yes.
There's the concept of consumer surplus and producer surplus.
Yes.
And when we're talking about, so we know that demand and supply, they have to be like that, right?
Yes.
Yeah, so this is our supply, and then that is our demand curve, the downward sloping one. So what it is this: here I've got price, and there I've got quantity. So consumer surplus, so you know that equilibrium will hold at point E, where here I've got price, which is equilibrium P star, and over here we have got quantity star, Q star, right?
Yes.
So consumer surplus is this area here, okay, which is the difference between the maximum price there, P, and the equilibrium price. So this area here, the shaded one, okay, that is what we call the consumer surplus. So the consumer surplus basically just shows the benefit that goes to the consumers. Okay. Yeah, it shows the benefit that goes to the consumers. And then producer surplus is the difference between the lowest price and the equilibrium price. So in short, this here is now the
producer surplus.
Yes, yes,
which is a benefit for the producer.
yes. Because for the producer, if things get worse, this guy will be forced to sell at the price equal to 0 there. But he goes on the market and finds that the price is actually P star. You see that? So he's going to sell this area, this whole area. So this whole area will become his surplus.
Oh yeah.
Then for the consumer, when you're going to the market, you are thinking that, well, I'll pay the maximum price, which is P there, the top there, at the top there. And then you go to the market to find that the price is P star. So it means that you will now be buying at a price which is lower than the price that you thought. So that will become your consumer surplus.
Okay.
So basically, those are the two concepts that I thought we should first talk about, even before we look at the question.
Okay.
Because the question is asking about the same producer and consumer surplus. Now, the only difference is that in the question, we have been given the functions. Hello. Good morning. How are you? Yeah. So now I understand working class. Oh. Oh. Ish. Okay. So, can I come through today? Okay. So, where? Charleston? No. Yes. Oh, I see. Tina. ShopRite. Avondale ShopRite. Okay, Avondale ShopRite. Oh, okay. Twin Palm. Okay. Okay. Okay, perfect. All right. Thank you so much. I'll do just that. All right. Thanks. Can you hear me now?
I can hear you, John.
So you can. Okay, so I was this is the person who's supposed to supply a gown to me.
Oh.
So
I
she was calling, letting me know that she has carried the gown, so I should go get it.
Yeah. Oh yeah.
Okay, let's continue.
So you guys are graduating with distinction, not so?
Actually, I don't know. Unza is just the hair on it. These guys never wanted to
And
give us
me.
distinctions. Yeah, so I've a merit. In short, all of us have got merits. The top 5.
Oh really?
We have merits, yeah. Then the rest credits. Then the other ones.
Oh yeah.
Yeah.
It is well.
Otherwise, I really wanted the distinction, but I just don't know how, you know. But
And
anyway,
you can't
the question is you can't even question them.
exactly.
You can't question them. So, you know, you go there plus chi for us is GPA. So it's really tough. Yeah, it's really tough under GPA.
True. Okay.
Yeah, but all in all, we thank God that we are graduating.
You have made it, yes, man.
Yeah, graduating third best. That just speaks a lot to me.
Yeah.
Especially when you look at our background, some of us, it's by the grace of God.
Alhamdulillah, we thank God. It's true.
Yeah.
For making it come this far.
Yeah, man. It's never been easy. Okay, so yeah. So now this question is saying that given the demand function, so the demand function is this one. PD. So they've given us what we call the inverse demand function. Okay? Because the normal demand function should start with Q.
Okay.
But this
one is setting the price.
Yeah, so this is what we call the inverse demand function.
Okay.
So I've got 113 minus Q squared as a demand function. Okay. And then the supply function is over here. It's P S, okay, is equal to open brackets Q plus 1 squared, like that. Okay. And then the first question is saying, they're saying that if the market is in equilibrium, what would be the consumers and producers surplus? Then interpret the two measures that you have computed. So what we know is that when the market is in equilibrium, okay, over here, demand should equal supply. So at that particular point, there is a price P. So the price from the demand side is equal to the price from the supply side.
Yes.
So in short, the first thing is for us to find either the equilibrium price or equilibrium quantity.
Okay.
So what we know is that we have got the price demanded this side. We also have the equation describing we also have the equation describing the what's this, the supply side there. Okay, so what we can do is let's solve for like we equate these two equations, then we find Q. Okay, we find Q, then after finding that Q, we put it back in either this function or that function to find the equilibrium price. Then later on, that is when we can apply consumer and producer surplus.
Okay.
So let's equate the two. So what we are saying that PD, the price from the demand side, should equal the price from the supply side.
Exactly.
Alternatively, what we can do is from this function we make Q the subject. Okay, from this function we also make Q the subject. Then later on we equate the two.
Okay.
So that we have got quantity demanded should equal quantity supplied when the economy is in equilibrium. So both approaches should give us the same answer.
I see.
But in this case, to avoid issues, let's just get the same functions the way they are.
And we equate them.
Yeah, then we equate them. Okay, so now if we do that, we have PD is this one, 113 minus Q squared. Okay, and then the demand is the open brackets Q plus 1 squared. So we have to open the brackets for this one here to make the mathematics simple.
Yeah.
So when we have x plus y in brackets squared, Okay, to simplify this, we say we square the first term. Okay, so this will be x squared plus, then we multiply the power times what is in the brackets. So this would be 2 times x times y. Okay, and then plus we square the last term, the y.
Okay.
So meaning that in this case we have q plus 1 squared. So this will be q squared plus, we multiply 2 times q times 1.
Which will be q.
Yeah, which will be q squared, and then plus c 1, because 1 squared is 1. So this means that here we are going to have 113 minus q squared is equal to, this part is equal to this one, right? So this will be is equal to q squared plus
q squared.
No. Actually, it's supposed to be 2 times q. That's 2q.
Yes, 2q.
Yeah, so it's supposed to be 2q, not q squared. Alright?
Yes.
So plus 2q plus 1, right?
Yes.
Perfect. So now we collect the like terms together. Alright? So let's get 113. Let's make sure that this q squared goes the other side.
Okay.
So 113. Oh no. Actually, the simplest is getting the q's on the left. So
okay.
we've got negative q squared, this one here. Then this guy here should cross the equal sign. This one. And when that happens, it's now going to become minus again, minus q squared, right?
Yes.
And then the 2q should also cross the equal sign. It also become minus 2q, right?
2q
is
minus
equal to
1.
So this
one is a constant.
Yes. But anyways,
equals 0.
Anyways, no, it's okay. Actually, if let's also let everything be on one side, since ultimately we should equate this to 0 and solve. So it's okay. Yeah. So these guys have. So we take the 1 also the other side, minus 1, and then we add the 113. Right?
Yes.
It's okay, right?
Yes.
Okay. So now if we simplify this, the negative q squared minus q squared, this will give us negative 2q squared. Can you hear me?
Yes, I can hear you.
Okay. My students have started calling these ones are people.
Oh my god. We'll be finishing.
Yeah, no, it's okay. Okay, so negative q squared minus q squared, this will give us negative 2q squared, right?
Yes.
So we have simplified this part alone, just this side, and then so we put back the negative 2q.
2q.
Yeah, then negative 1 plus 113. This will give us plus 112.
Yes.
So we are saying this is equal to 0. Right?
Yes.
So to simplify this, we can just divide throughout by negative 2, since this can be simplified. Right? Yeah, so that when we cancel this, cancel that, we have got q squared. The negative and negative, we've got plus q. Right? Then minus here. So 112. 56, right?
Yes.
Minus 56 should give us a 0. Right?
Yeah.
So remember, we want to solve for q. And again, this is a quadratic equation. So let's quickly use the formula method, because that one is simple and easier. let's use the formula method. Okay, so as usual, x is equal to negative b plus or minus the square root of b squared minus 4ac everything 2a. So x will be, so in this case our negative b will be the one here, isn't it?
1. True.
Yeah, so this will be give us negative 1, right?
Yes.
Plus or minus the square root of, so b squared, this will be 1 squared, isn't it?
1 squared.
Minus 4 open brackets, our a is a 1 here.
1.
So I have 1 times 56, right? Everything over 2 times a, but the a is 1, which is just a 2 anyways.
Yeah. Do we get 56 or we add a negative?
Oh, sorry. Yeah. We say negative 56. So times negative 56. Yeah. You're right. So x will be negative 1 plus or minus the square root of, so 1 squared is 1. Right?
Just 1.
Yeah. And then in the brackets I've got 1 times negative 56, which is going to give us negative 56. So negative 56 times negative 4, the answer must be positive.
We have 224.
Okay, so we have plus 224 divide by 2, right? So x is equal to negative 1 plus or minus, what's the square root of 1 of 225? 15. Okay, perfect. So over 2, meaning that our q can either be negative 1 plus 15 over 2, or q is going to be negative 1 minus 15 over 2, right?
Okay.
So already negative 1 plus 15, that's a 14.
Yes.
14 divided by 2, this will give us a 7, right? Then here, negative 1 minus 15, this is negative 16. Negative 16 divided by 2 will give us negative 8. But remember, there can't be a negative output. Meaning that our value for q is 7.
Okay. So that's what you pick.
Yes, so we pick the positive.
Yeah.
Pick the positive one. That's okay, right?
Yes.
Okay. So now we can apply this concept now to find the consumer surplus and the producer surplus. So let's start with consumer surplus. Or anyway, so let's find the price first of all. So PD is equal to 113 minus Q squared, right?
Yes.
Which will be 113 minus, our Q is 7.
Yes.
So minus
7 squared.
Which is 49, right?
49, yes.
So just do 113 minus 49.
That's 49. 64.
Exactly. So the price, the equilibrium price, the price that is going to equilibrate this market is 64 kwacha.
Okay.
Now can we get what we call producer surplus? No, let's start with consumer first. Let's start with consumer surplus. Anyway, we know that the price is 59. Oh, 64.
64, yes.
Okay, so now let's start with consumer surplus. So to find the consumer surplus, we apply the concept of integration. So the formula is that to find consumer surplus, we are going to integrate from 0 to equilibrium quantity Q. Okay?
Okay.
Of the demand function. Okay, so we're going to integrate this for the demand function, okay, minus price.
I see.
But remember that in this case, we are integrating with respect to Q. Right?
Yes.
So now, since we're looking for the consumer surplus, we are going to get the demand function. Okay, so in short, it's more like we're integrating from 0 to Q. The demand function, which is this one here, 113 minus Q squared minus price. Okay, minus price, but everything with respect to what? To Q, right? So we know that when we integrate 113 minus Q to the power 2 with respect to Q, this will be 113 Q, right?
Yes.
Minus Q to the third power, isn't it? Over 3,
Yes.
minus, when we integrate P with respect to Q, this will be P times Q, right? Remember?
Yes.
Yeah, those basics we did.
Oh, this is right. Wrong.
Yes.
Yes.
Okay, so we are almost there. We are almost there. We are almost there. So now, since we now have Q, we have B, then we can solve this. Okay, but of course we are integrating from 0 to maximum Q. But we know what the maximum Q is what? We said it's 8, right? Did you say 8? 7. 7. Yeah. So we are integrating this from 0 to 7. So what we know is that we know what Q is. We also know what P is. So this is more like saying 113 open brackets. We replace with here we put what is Q, and we say that Q is 7, right?
Yes.
Minus 7 to the third power divided by 3, right? This whole thing here minus P times Q, and our price was 64 times 7 exactly. So can we do this? Just simplify this.
So we have 113 in the brackets. We're going to have 343.
So, in this.
Please no, I've made a mistake.
So you can do them individually.
Yeah, 113 by 7. I have 791.
791 minus.
Then 7 by 7 by 7. This is 343.
Divide by 3.
You go around. Yeah, you can either go that side or this side. You're welcome. Sorry, 343.
Okay, so you have 343. That is after dividing by 3.
Okay, wait. Divide by 3. I have a 114.3.
114.3.
Yes.
Okay, so minus, we put back the. So now multiply 64 times 7.
64 by 7. 64 by 7. Some things you even refuse it.
Yeah. Are you there?
Yes, 448.
448.
Yes.
So now, what it is this? Well, actually, no. It's okay. Yeah. So can you punch this?
Okay.
Can you punch this?
791 less 114.3 less 448. I have a 228.7.
228.7.
Yes.
Okay. So since we have done the replacement already, I'm now thinking, yeah, because already even if we put the 0 throughout, this whole thing is just going
It
to
will still
collapse to
give us
0.
0.
Yeah, so this becomes our consumer surplus. So the 228.87 becomes our consumer surplus.
Yes. So in an event, sorry, George, if
Yeah,
we
it's okay.
had maybe a 2, we have a 7 and a 2, and where there's 0.
Oh no, we always integrate from 0 to Q.
Okay.
So it's gonna be
Okay.
always that the first turn is 0 down there, and then you're integrating up to Q.
Okay, that's fine.
Okay, perfect. Okay. And now the difference between consumer and producer surplus. So with producer surplus, okay, 8-ish surplus, is that to find producer surplus, what we do is we integrate its now price minus the supply function. Minus the supply function, everything with respect to Q, so DQ. That's what the difference is. So producer surplus is now going to, yeah, it's going to equal. So we're still integrating from 0 to Q of
7.
Of the, so I've got P minus, what was the, let me check the supply function. Let me check.
The Q minus squared.
After simplifying, it gave us what? We had Q squared plus 2Q, then plus 1, right?
Yes.
So it would be P minus this, the Q squared plus 2Q plus 1 with respect to Q. Okay. That's okay, right? Okay. So quickly. Okay, so can we integrate this with respect to Q? So we know that if we integrate P with respect to Q, this will give us PQ, right? Minus, open brackets, when you integrate Q squared, this will give us Q to the third power over 3 plus 2Q squared over 2, then plus Q. From 0 to 7. Yeah, so we now know at PQ we have P and Q. So it's the same thing, 7 times 64. Which gave us
448.
Yeah, so 448 minus, okay, Q to the power 3, and our Q is 7. So it's the same thing, we do the same thing, 7 times 7 times 7.
That's
Then
343 divided by 3. It's 114.3.
So 114.3
Yes.
plus we've got 2 times Q squared, and our Q is 7. So it's more like just saying 49 times 2.
Yeah.
So 49 times 2 divided by 2.
Divided by 2. It's 49.
Okay, so we get back to our 49, yes. Then plus 7. Right?
Yes.
Of course, the moment we say minus is 0, I mean everything is going to collapse to 0. When we say minus, then we put back the 0, everything is going to collapse to 0. Perfect. So when we solve this, so just punch this, we see
plus 49 plus 7. I've found for the brackets first. Yeah, it has given me 170.3.
So remove that from 448.
It's 277.7.
277.7.
Yes.
Yeah, so it means that this is the producer surplus, and then this is the consumer surplus.
Yes.
Yeah, which means we
And
have
this had a lot of marks, 25.
no wonder, yeah, because there's some gymnastics
A
because
lot of work.
yeah. So this was a test.
The one he gave last in 20, is it 2021?
Oh, I see.
Yeah. So he sent us to say this is a sample test.
Ah, okay, perfect.
Yeah.
So chances are so high that if you are lucky, he might repeat.
Some questions, but though he did say, he likes repeating some questions, but he says, because the first test was bad, so he says, I really want you guys to start, but of course I'm not going to bring exactly the same things. I'll change a few things so it can replace.
Oh, yeah.
But I'm sure the principle and concept is the same.
Yes, please.
It's
yes,
just application.
please.
Yeah.
Just application. Yeah, so I'm
Then there was a
positive.
part also. Yeah, I'll try my best.
Yeah, please. I'm positive that he can bring this, something like this, consumer surplus.
He
producer
will.
surplus.
Yeah, I know.
He's-
Integrals he will bring because he likes that, but confusing with a power, with a cube, what?
I see. Yeah, but the moment
Yeah.
you know how to solve quadratic equations, then you will not have issues.
Yes.
The moment you know on how to deal with quadratic equations, then you're on the safest side.
Yeah, plus the points, even those are coming definitely. The
Yes.
critical points.